The next test we're going to move on to now is the second type of chi-square, which is called a chi-square test of independence. So we just did a goodness of fit test. We're now on to a test of independence. And this test is a test of association or a test of the relationship between two categorical variables. So we want to see whether one categorical variable is associated with another categorical variable, whether there's a relationship between these two categorical variables. And what that means in terms of having categorical data is to see if the proportion of observations across the categories of one variable are related to the proportion of observations across another variable. So if there is an association, if there is a relationship, that means that the variables are not independent. So we want to see if the proportion of observations across categories of one variable, whether they're related to the proportion of observations across another variable. If they're not related, if there's no association, then we can say that the two variables are independent. That's why it's called a test of independence. And another way of expressing that is to see whether group membership of one variable is related to group membership of another variable. Group just being another word for categories. And another way of expressing that is to see whether we can think about the chance or the likelihood of something occurring in the dependent variable. So whether any individual's chance of being in one category of the DV is related to their category membership of the independent variable. That might all sound a little bit kind of too wordy at the moment, or a little bit like it doesn't make a lot of sense. And that's just because when we think about categorical data, as I said before, it is a different way of thinking about numeric data, but hopefully when we get into the example, this will make more sense when we get into a couple of different examples. So in terms of displaying the data for categorical variables, the way that we would display this in terms of their potential relationship between the two variables would be through a contingency table. And a contingency table is also called a cross-tabulation, which is also called a two-way frequency table. All those things mean the same thing. And what a contingency table or any of those other things are is just a way of expressing, in terms of rows and columns in a table, each of the observations in each of the combinations of categories between the two variables. So this is taken from your textbook. This is a pictorial representation of a contingency table here. And we've got two variables. We have hair color, blonde and brunette, as our row variable here. You can see that this is the variable that makes up the rows of the table. And we have satisfaction with hair color as the column variable, as our second variable. And that variable has two categories or two values, satisfied and unsatisfied. And the number of little images that you can see in each of the cells here represents the sample size for each of those combinations of categories. So you can see that there are 3 satisfied blondes, there are 4 unsatisfied blondes, there are 4 satisfied brunettes, and 2 unsatisfied brunettes. So this is a representation of a contingency table or a cross-tabulation or a two-way frequency table. Okay, so as you can see, we've got our hair color as our row factor and satisfaction as our column factor. And if you do have the distinction between an independent variable versus a dependent variable for your two categorical variables, then convention says that the independent variable goes as the row factor, whereas the dependent variable goes as the column factor. There's no particular reason for that. That's just the way that these things tend to be expressed. That's just convention. And in this instance, hair color is our IV and satisfaction is our DV, because just logically it makes sense that if we're talking about understanding people's satisfaction with their hair color, that hair color is used to predict their satisfaction with their hair color. That's kind of the direction of the relationship that makes sense. It wouldn't make sense for it to be the other way around. Okay, and what we're interested in understanding here is whether hair color is related to satisfaction. So whether the difference between brunettes and blondes predicts a difference in how satisfied versus unsatisfied people are with their hair color. So is hair color related to the probability or to the chance of someone being satisfied with their hair color? And we can represent the data that are in the table here in terms of a graph, and that appropriate graph would be called a clustered bar chart, and that's exactly what you see here. And the clustered bar chart is representing the exact same thing that the table is, it just does it in terms of a graph versus numbers in the table. And what you can see here in terms of understanding whether there is an association between the variables, we're trying to see whether the proportion of people who are satisfied differs between blondes and brunettes. And what you can see looking at this graph, just like looking at the table on the previous slide, is that for blondes, there's slightly more of them who are unsatisfied versus satisfied, meaning that for blondes over the left-hand side here, the blue bar is slightly higher than the red bar. There's slightly more unsatisfied versus satisfied blondes. Whereas for brunettes, there's slightly more satisfied versus unsatisfied brunettes. The red bar is higher than the blue bar. And that's representing what an association would be. An association would mean that your hair color changes how likely you are to be satisfied. That people with a different hair color have a different likelihood or chance of being satisfied with their hair color. And even though we're not going to do the statistical test on this example, we'll go into the next example, which is a bit more meaningful. What we're seeing here is that there is a relationship between hair color and satisfaction, because brunettes are slightly more likely to be satisfied compared to blondes, i.e. for brunettes, there's more satisfied versus unsatisfied brunettes, whereas for blondes, there's more unsatisfied versus satisfied blondes. So moving on to our chi-square test of independence more formally. As I said before, what it's doing is testing the association or the relationship between two categorical variables. And it's trying to see whether the proportion of observations across the categories of one variable is related to the proportion of observations across another variable. Oops, sorry, going backwards there. So whether group membership of one variable is related to group membership of another variable, whether the category that you're in on one variable relates to or predicts the category that you're in on the other variable. So if the chance of being in one category of the DV is related to your category membership of the independent variable. And what we saw in the previous example was that people's likelihood of being satisfied with their hair colour changed depending on their actual hair colour. So brunettes had a higher likelihood of being satisfied with their hair colour compared to blondes who had a lower likelihood of satisfaction with their hair colour. So to move on to the more formal example that we're using here, the topic here is in social psychology. It's a particular example we're using from a paper that was published here. And what we're looking at here is people's intentions to follow through with some kind of behaviour and looking to see if we can change people's likelihood of following through with that behaviour depending on giving people reminders or giving them different cues to try and increase their chance of following through with a behaviour. So the kind of context here is thinking about people's intentions to do something like, say, a New Year's resolution, going to the gym, eating more healthily, anything like that, and trying to understand whether the kind of cues that you could give people, particularly in the form of reminders for this particular experiment, whether that can increase their chance of following through with a particular behaviour. So the study design of this particular study is an experiment. It's a between subjects manipulations. People were randomly allocated to different conditions. And what they were looking at was people's likelihood of actually answering a particular way on a quiz where they got money for answering correctly, but whether they could override their desire to answer correctly to one particular question of a quiz because they could get an extra bonus for that particular question. So say that again. Participants were completing a particular quiz in the experiment and they received money for each correct answer that they got on the quiz. But for the last question, the final question, they received an extra bonus, an extra financial bonus, if they selected the incorrect answer. And so they had to remember to do that from when they were told at the start of the experiment through to when the question came up at the end of the quiz. So they had an intention to give the wrong answer, the incorrect answer on the final question, and they had to remember to do that and follow through with their intention. So the research question in general was whether a reminder, particularly in terms of an association, a reminder in the form of association, and participants were told in this particular condition that if a picture of an elephant was displayed, that was acting as a reminder to give this incorrect answer and therefore receive the extra bonus. So whether that reminder could cue individuals to follow through with their intentions and therefore receive the bonus on the final question if they gave the incorrect answer. And the hypothesis here, the particular research hypothesis, is that participants who receive the reminder through the association would be more likely to receive the bonus than those who received no reminder. So giving people this particular kind of reminder, they thought would increase their likelihood of following through with their intention, and therefore they'd be more likely to receive the bonus because they received the bonus if they followed through with their intention. And we've got two variables that are key variables in this particular example. We've got their condition, their group variable, and that's got two levels or two categories. Those who are in a no reminder, essentially control group, versus those who were in a reminder through association group. So the ones who actually got the reminder. And then our outcome variable here, our dependent variable, is the final problem. And that's, again, a categorical variable with two levels, two categories. Those who didn't receive the bonus because they didn't give the incorrect answer versus those who did receive the bonus because they did give the incorrect answer. And that's the citation for the paper. So what we're looking at here is whether there's an association between condition and receiving the bonus. So whether those who were in the reminder through association group were more likely to receive the bonus compared to those who were in the no reminder control group. So the first step for any kind of data analysis would be just to describe the variables themselves, so to run some summary statistics, some descriptive statistics on the variables themselves, just to see what the distributions are like. And for categorical variables, we know that the appropriate summary is in the form of a frequency table, which is what we've got here for our first variable, our condition variable. So this is our independent variable, and we've got two groups here. There's the no reminder group versus the reminder through association group. And people were randomly allocated to one of these two groups, which is why we've got an almost perfect split of participants between the two groups. So 153 people in the no reminder group, 152 in the reminder group. And you can see 305 people in total. And our second variable, which is our outcome variable here, our dependent variable, is whether people did or didn't receive the bonus. So if they didn't give the incorrect answer, they didn't remember to give the incorrect answer, they didn't receive the bonus. If they did remember to give the incorrect answer, then they did receive the bonus. And what you can see here is that most people did remember and most people therefore did get the bonus. So we've got 222 of the 305 people, which is 73% of our sample, who did get the bonus, whereas only 83 people, or 27%, who didn't get the bonus. So the majority of people could follow through with their intentions. The majority of people did remember to give the particular answer, the incorrect answer, and therefore received the bonus on this experiment. And to get the data, just like always, that's the command that you need to type into the Stata command line, the web use set command firstly, and then to call up the data set itself, the web use Rogers 2016, which is the data set in particular. Okay, so the next thing that we would want to see would be to run these kind of crosstabs table, this contingency table or two-way frequency table, to see if we can see any evidence of an association between these variables. So that's what we've got here. We've got our independent variable as our row factor on the left here. We've got that condition variable. And then we've got our dependent variable, whether people did versus didn't receive the bonus, as our column factor there. And you can see that just looking at the numbers, it's a reasonably even split in terms of in the no reminder condition, whether people did versus didn't receive the bonus. So 63 people in the no reminder condition didn't get the bonus, whereas 90 people in the no reminder condition did get the bonus. But in the forced reminder through association condition, there's a much more uneven split. So the large majority of people in that group, the reminder group, did get the bonus, 132, versus only 20 people who didn't get the bonus. So at this stage, that does look like there's an association between the variables, that the breakdown of people across the different categories of the dependent variable is different across the two different categories of the independent variable. And an easier way of seeing that, particularly when you're first learning, rather than through the numbers in the table, is through the clustered bar chart. And that's what we've got on the right hand side here. So you can see, just like the table showed us, in the no reminder condition, there's a reasonably even split of people. There's a few more people who did versus didn't get the bonus. The red bar is a bit higher than the blue bar in the no reminder condition, but it's more even than in the forced reminder through association condition. In the forced reminder through association condition, many more people did get the bonus, the red bar, compared to didn't get the bonus, the blue bar. And so that's essentially representing the fact that it looks like there's an association between these two variables. It looks like the condition that you're in changes the likelihood of getting the bonus. It looks like people who are in the reminder condition were more likely to get the bonus compared to people who weren't in the reminder condition. And I'm just going to show you in the next couple of slides a few more ways to get a bit more information out of this two-way table, frequency table, this contingency table. So if we use the same syntax, the tab or tabulate syntax, and then list our two variables, our IV and our DV, but if we put a comma and specify the word row after that, then what data will report in this table for us now? The first row in each of the individual cells are the frequencies, just the same as what was on the previous slide, slide 25. Whereas the second row in each of the cells gives us the percentage of people within that category of the independent variable who falls into each of the categories of the dependent variable. And in particular, when the numbers of people across the two categories of the independent variable are a bit different, they're not very different here, they're almost identical, but in situations where the numbers of people across the categories of the independent variable are different, looking at the percentages, the row percentages, as opposed to the raw frequencies, just the observed frequencies, often gives you a better idea of whether there's an association between the variables. And so what you can see here, it's less relevant in this particular situation because we've got almost identical numbers of people across the two categories of the IV. But what you can see here is that in the no reminder condition, 41% of people didn't receive the bonus, 59% of people did receive the bonus. So it's reasonably similar, 41, 59%. Whereas in the reminder condition, it's a much different breakdown of people across the two categories of the DV. So in the reminder condition, only 13% of people didn't receive the bonus, whereas 87% of people did receive the bonus. So it's a much bigger difference between those who did versus didn't receive the bonus in the reminder condition compared to the no reminder condition. So I said to you that on the graph, the clustered bar chart on the previous slide, slide 25, is representing an association. At this stage, it looks like there is an association. Obviously, we haven't done a statistical test. We can't say that it's a significant difference, but looking at that graph on slide 25, it does show that there is possibly an association between the two variables. So I thought it would be helpful for you to get your head around what no association would look like, and that's what the next couple of slides are doing. So this is an example, this is using the same example, but the data are different just to represent the different pattern of results that we could see. This is an example of what no association could look like or might look like. So it's not so much about how high each of the bars are for each of the four different conditions, for each of the four different groups. What it's about is the representation of the red versus the black bars in one group compared to the red versus the black bars in the other group. So what you see here is that in the no reminder condition, there's a similar breakdown of people who did versus didn't get the bonus, whereas in the forced reminder condition, again, there's a similar breakdown, a similar comparison of people who did versus didn't get the bonus. So that's an example of what no association between condition and bonus could look like. And another example of what it could look like is this slide, slide 28 here. So what this shows is that even though there's a lot more people in the no reminder group than the forced reminder group, and that's represented by the fact that the bars, both of the bars, are much taller in the no reminder group compared to the forced reminder group, the pattern of comparison between the red and the black bar in the no reminder group is similar to the pattern, the comparison between the red and the black bar in the forced reminder group. So if you compare both this graph and that graph with that graph, hopefully this graph on slide 25, you can get more of a sense of how this is showing us that it looks like there is an association between the two variables. because the pattern of red versus blue bars is quite different between the two categories of our independent variable, between the no reminder and the forced reminder through association groups.